Hello everyone, Jai Hind to all. Welcome in digital studio of Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, I am going to discuss about linked list. This topic comes under the data structure subject. First, we want to discuss what topic we will discuss here. The first topic is definition of linked list. Before discussing the linked list, we first discuss what is main advantage of linked list over the array. This is the main point which tells about why we have to using linked list in place of array. Second one is definition. Then we have using types of linked list. There are following types of linked list: singly linked list, doubly linked list, circular linked list, circular doubly linked list, and header linked list. And the last one is a program. This program shows how we have to create a node by using linked list. This is the main topics which is covered in this video lecture. Now, first we want to discuss what is the advantage of linked list over array. The first advantage is data structure, dynamic data structure. A linked list is a dynamic arrangement, so it can grow and shrink at runtime by allocating and reallocating memory. This means array is not supporting the dynamic data structure, but linked list support the dynamic data structure. Second one is no memory wastage. That means if we have to a limited memory, then by using linked list, we have to utilize maximum memory by using the linked list. Second one is implementation. Implementation is also easy in terms of other data structure. So we are using linked list. Next point is insertion and deletion operation. In case of array, insertion and deletion operation take too much time, but in case of linked list, insertion and deletion are easier and quite less time consuming. So we are using linked list also. Next one is flexible. This is because in linked list are not stored in contiguous memory location, unlike the array. Array is stored inside the memory in a contiguous memory location, but in case of linked list, we have to creating a node at any place and link the node to the any nodes present at any location. By using such method, this data structure is flexible. Next point is efficiency for large data. This is the efficient when our data is large. That means if I have the 1,000 lakhs of data, at that case, the linked list is efficient as compared to other data structure like array, etc. Next one is scalability. Scalability means containing the ability to add or remove element at any position. In case of linked list, we have to add element at the beginning or at the last or at any point between first and last easily. So the linked list is the more efficient and more scalable as compared to other data structure. The next is what is mean by linked list. This is the definition which is covered in these slides. The definition of linked list is a linked list is a linear data structure in which the elements are not stored at contiguous memory location. That means elements are which may be located at any place. We have to connect with node, and such type of list is called linked list. That means there is a connection between nodes. This nodes is according to types. There are different partition, which may be one partition, which may be two partition, or which may be three partition, depending on conditions. This is a basic diagram which show the linked list. Here, this shows nodes. We can link list. We can also define linked list linked list is the collection of nodes and each node is divided into different parts. First part contain data. That means this part contain data which may be integer, which may be float, or which may be character. And second part is the next part, which is also called link part. And it contains the address of next node in the list. So we can also define linked list is a collection of node and each node is divided into two parts in case of linear linked list, and node is divided into three parts in case of double linked list. But here we have to discuss the definition of linear linked list. So the list is the collection of nodes and each node is divided into two parts. The first part contain data and second part contain link, that is also called a next pointer field. Okay. Now the data is the simple data, but the next is a variable which is a special kind of variable called pointer, and it contains the address of next node. And the next node is also contain the address of next node, and next node is contain the address of next node. If this is the last node of the data list, so this part contain data and the last part contain null. Null means the list is empty. So this method is using to represent the linked list inside the memory. Now we are going to discuss types of linked list. Their first type is singly linked list. Then we have discussed about double linked list, then circular linked list, then circular double linked list, and then header linked list. Singly linked list is the simpler data linked list. In this case, the data structure is collection of nodes like this. This is a node, this is a node, this is a node, and this is a node. Collection of these nodes is called singly linked list. In case of singly linked list, each node is divided into two parts. First part is called data and second part is called link part or next node address part, which contain the address of next node which is present in the list. The first part is contain data. Here data is A, here data is B, here data is C, here data is D. The link part of this data is contain the address of next node. This link part is contain the address of next node, and this link part is contain the address of next node. Here there is no next node, so we have to put here null. Null means there is no other node present in the given list. This is the structure of singly linked list. A singly list is also a linear data structure in which elements are not stored in contiguous memory location and each element is connected only to its element using a pointer. We have using pointer in case of linked list because this linked list is show the property of dynamic memory allocation. So by using pointers, we have to implement linked list in a dynamic form. Now the next point is doubly linked list. In case of doubly linked list, each node is divided into three parts. There is no difference between definition. Also, it can be defined as a doubly linked list is a collection of nodes and each node is divided into three parts. Here, the first part is called address of preceding node. Second part is contain data and third part is contain the address of next node. By this method, we have to show the double linked list. If there is no preceding node, so we have to put here null, and here there is no next node, so we have to put here null. And each node is divided into three parts. One part contain data, one part contain the address of preceding node, and the other part is contain the address of next node. That means we have to process in both direction. we have to process in backward direction or we have to process in forward direction, depending on condition, which direction we have to use for processing. The next one is circular linked list. In case of circular linked list, the last node null pointer is point to the first node. The definition is similar, but the difference is, in case of linear linked list, this link part is contain null. But if we want to implement this linear linked list in terms of circular linked list, then we have to point the last node with first node, and this type of data structure is called circular linked list. The circular linked list is a linked list where all nodes are connected to form a circle. Circle means there is no end node. We have start with any node and process up to any node. No last node, then the list is called circular linked list. In a circular linked list, the first node and last node are connected to each other, which form a circle. There is no null or end point. The list is in the form of circle like this. Take a example like this. This is the partition of nodes like this, and this is divided into this data connected to this data and this data. In such type of data structure is called circular linked list. Now, a circular linked list is divided into two parts. The first one is circular singly linked list. In case of circular singly linked list, the last node point to the first node. The last node point to the first node, and such type of list is called circular singly linked list. Second one is circular doubly linked list. In case of circular doubly linked list, the first node which contain the null, this point to the last node, and last node in case of doubly linked list, that point to the first node, and such type of data structure is called circular doubly linked list. There is a little difference between doubly linked list and circular doubly linked list. In case of doubly linked list, here we have to put null, and here also we have to put null, because there is no preceding node to contain this point address, and here there is no next address, so we have to put here null. But in case of circular doubly linked list, this null is pointed to the first node, and this null is pointed to the last node. By using this method, we have to convert the given linked list into doubly circular linked list. The next one is header linked list. In header linked list, we have to add a special node at the starting of the list. That node is called header node. And there are two types of header linked list. The first one is grounded header linked list. In case of grounded header linked list, we have to add a header node at the beginning of the list, and before header node, we have to add a pointer that is called start or head. This node is also called head. This is also called head or start. This point to the header node, and header node point to the first node in the given list. And the last node link part is contain null. That means end of the list, and such type of list is called header linked list. Second one is circular header linked list. In case of grounded header linked list, we have to put here null, that indicate the end of the list. But in case of circular header linked list, the last node which contain the null, which link part is null, that point to the first node, and such type of circular linked list is called circular header linked list. We showed in the diagram here. This is the start. We discussed earlier that this is also called head. This is the head pointer which point to the first node in the list. This is the header node which points to the first data part in the list. And in case of grounded circular linked list, this part is null. But here this node is point to the first node, that is header node, and such type of list is called circular doubly linked list. In grounded circular linked list, we have to put here null, but in this link part is contain the address of first node. Such type of difference is in the both cases, grounded circular linked list and doubly circular linked list. Now we are going to show a program, and this is a C code which is used to create a single node. By using linked list, how we have to create a single node, we are showing in this code. First, we want to recall what is the syntax of structure. Structure is a data type. Structure is a block of code which contain different data types contiguously. That means if you want to print name, mobile number and address, name is the group of characters, mobile number is the integer value, and address is also group of characters. By to such type of information we want to print, so we have to use structure. Without structure, we can do this work by using array, but we need three different data types to print name, a character data type, to print mobile number, a integer data type, and then print address, a character data type. So there are typical to implement such type of information by using array. To overcome such type of complexity, we have to using structure. That means structure is the collection of different types of data structure. Here we have to using two header file. The first header file is stdio.h, that is used for standard input output header file, and second one is stdlib.h. This is the standard library header file which is used for dynamic memory allocation. As we discussed earlier, linked list support dynamic memory allocation. So we are using here the concept of dynamic memory allocation. First, we want to show what is the syntax of structure. This is the main syntax of structure. We have to here create a node, and the node contain two types of data. The first one is integer type data, and second one is pointer type link. That means if you want to show theoretically, a node is a location in memory which having two parts. The first part is data and which contain integer value, and second part is link, that is the pointer type. That means this contain the address of next node in the list. By using this syntax, we have to decide what type of data to be node stored. Here we have to store integer value at data part, and we have to store a pointer, that means address at link part. By using this code, only we have to decide a node having two parts. The first part is the data and second part is the link. This is the main code which is used to show how the list is created. Here we have to using a struct node pointer head equal to null. This is a pointer variable which point to the very first node in the list. You know that linked list is the collection of nodes in which each node is pointed to the next node, and the first node address contained by a special node, and that is called head. Like this. This is the linked list. Here we create head pointer. This is the main nodes which points to the first node in the linked list. Here we have to using head equal to struct node malloc size of struct node. This is the syntax of malloc function to create or link a node to the next node. And here we are using struct node, that is the typecasting. If we are not using this syntax, there is no error comes, because here we are not going to typecasting, but we using standard syntax to create a node. This is the malloc function which is used for dynamic memory allocation. Here this is the size of an struct node. This is the main syntax to create a head. After executing this code, what happened? I discussed earlier, when we creating a structure type node, then the node structure like this. This is the data part and this is the link part. And when we have to create this, a head is created. A head is created, and the address of or the value of head is null. Null means 0. When we have to execute this line, head is point to the first node. The link is established. That means if this node address is 200, then after executing this statement, the head contain 200. This means when executing this code, the head contain the address of first node. Now this is link the first node, but till now we does not enter the value of data and value of link part. After that, creating a nodes and linking with head, we have to insert the data into the data part and the address at link part. This is the code which is used to insert a value at the data part. We have to using head data. That means this is the head. That means 200, and 200 data part is this. By using arrow, we have to enter at data part location, and we have entered the value 45. After opening, we have to using head implies data. We goes on this point and enter this point. The value is 45. We have entered. By using this operator, we have to open the gate to enter at data part. After that, head implies link equal to null. Why we have putting here null? Because at the starting we have discussed that this program is to create a node, a single node. So in this list, only one node. So the next link part to be null. So by using same syntax, head implies link, we have to open this gate and enter here null. That means this is the last node. And earlier I discussed that this program is only covered to create a single node. So we have enter here null. If we want to add another node, so by using this basic concept, we have to create also another node. But by using the concepts, we have to create number of nodes by using the concepts of head. And how we have to create two nodes, we can show here. This is the code for creating a single node. And if we want to create two nodes, then after this, we have to declare a head, one more head, and that name is head 1. Same syntax written to be here, struct node, pointer type head equal to null, and then this syntax is also same. We have to take in here head 1, then a node is created, and this is pointed by head 1. Now we have to link this node with this node by using the keyword head implies link equal to head 1. That means the address of this node is going to this link part. After linking, we have to insert the value at head 1 by using the same code. Head 1 implies data equal to 100. We have entered here 100 and this is the last node, so we have to put here null. By same syntax, head 1 implies link equal to null. We have to put here null. By using such method, we have to create number of nodes one by one sequentially. And this is all the basics of linked list. If any doubts or suggestion, comment in the comment box. Thank you. Thank you so much.